Good morning, good afternoon, and good evening to all the participants joining us today for this particular lecture from the entire globe. It is Dr. Anu Joseph, President of Indian Geotechnical Society, Professor Alessandro Flora, the Chairman of Technical Committee 301. Um, you know, our members of Technical Committee 301, Margottini, the faculty members, professionals, practitioners of technical committee. I extend a warm welcome to all of you to this lecture series on conservation of heritage sites. Today, the lecture 3 will be delivered by Professor Claudio Margottini. He is a UNESCO chair at University of Florence and president of IAEG, ethically, and he is going to deliver today a talk on engineering geology at Frontline of World Heritage Protection. I request Professor Alessandro Flora, the chairman of Technical Committee 301, to address the participants.
Yeah, thank you, Dr. Chabda. First of all, let me thank the Indian Society of Geotechnical Engineering for hosting these webinars because there is some, coordination work to be done that I really appreciate. I want to remind to people not knowing it very well that the Technical Committee 301 on historic sites is one of the committees of the International Society of Soil Mechanics and Geotechnical Engineering. And it is important to introduce these webinars to remind you that there are three groups of technical committees in our international society. The ones that start with 100 are involved with fundamentals of soil mechanics. The ones which start with 200 are involved with applications of geotechnical engineering. The ones starting with 300 are the ones involved with the impact on society. And we are the TC 301. So we are the first one of the technical committees having an impact on society. So because of this, we are very much involved we are trying to cooperate with people from different expertise because the goal of the committee is to promote and diffuse the culture of preservation within our community, but also to share, to have a common way of thinking with people coming from different expertise. And because of these, we have launched a series of webinars, and today we're going to hold the third one. And the first one was held by Professor Gottardi, who is here, and we say hello to him. And Guido Gottardi is a professor of geotechnical engineering. This is important. The second lecture was delivered by Professor Arun Menon, who is a structural engineer, is a professor of structural engineering. And so coming from looking at the historic sites from a different point of view. And the third one, which is the one we're going to listen today, is the one delivered by Professor Claudio Margottini, who is a professor of engineering geology. So he's also looking to the preservation of historic sites from a point of view which is very close to ours, but slightly different. And so it is important that we open up our mind, we listen to people who don't exactly look at things in our same way to share discussion and possibly have a common way of thinking. So we, of course, invite anybody interested in delivering a lecture in the next future to contact either me or the secretary, Dr. Chabda, to discuss possible continuation of this series of webinars. So I don't want to take any more time because the more important thing is to listen to Claudio. But so I give the word to Dr. Chabda again, who is going to introduce the president of the Indian Society.
Yeah, thank you, Professor. Now I request the chief guest of this lecture series, who has accepted our invitation, Dr. Anil Joseph, President of Indian Geotechnical Society, to address the participants.
Yeah, very good day, all of you from different part of the world. It's a pleasure for me here and one of the most dynamic TC, which is very active, TC 301. First of all, I would like to congratulate Alexandra Flora for leading as the chairman and also the very simple way he presented what are the different technical committees of the ISSMGE leading with fundamentals, application and impact on society. Thank you, Alexandra, for bringing that to the notice of all the participants. And thank you, Jidesh, for doing a great job as always, making sure that the activities are continuing and moving in all the very best for you team. And today I don't want to stand between Claudia who's we all are waiting to hear for on the lecture on engineering geology at the front line of World Heritage protection. It's a very important aspect he will be talking to us. So it's a good opportunity. But before I hand it over, I would like to thank everyone for inform everyone that I as the Vice President of Asia of ISSMG and will be taking charge on June 14th at Vienna. And I hope that TC T301 also will have a committee meeting going to happen in Vienna where we are all coming together, where it all began. Where Carl Tarsagi came up with the theories of the fundamentals of this. And we will be visiting the first laboratory of Carl Tarsagi also during the process. So look forward to see many of you there in Vienna. And let us keep the journey going. All the best wishes, Alexander Flora and team. And thank you, Claudia, for joining us to deliver this wonderful lecture. I look forward to hear from you. Over to you, Jidesh.
Thank you, Dr. Anil Joseph, for addressing the participants. Thank you, Indian Geotechnical Society, for giving all the support for providing us a Zoom platform for conducting this meeting. Now, I request Professor Alessandro Flora, the chairman of Technical Committee 301 Historic Site, to introduce the speaker.
Okay, well, Professor Claudio Margottini is a very well-known person in the field of the preservation of historic sites. He's full professor of civil engineering geology, and president of the International Association for Engineering, Geology, and the Environment. And he has been deeply involved with UNESCO in the preservation of many sites, as you will see in his presentation. He's also been a adjunct professor at a UNESCO chair at the University of Florence and also at the Galilei University in Egypt and at the National Research Institute for Astronomy and Geophysics, also in Egypt, because he has a very good connection with Egypt because he has been the scientific and technological attaché for the Italian embassy for a while in Egypt. So he has a very good connection with that country, with a lot of sites to be preserved. So he has received a bunch of honors and awards during his career. He has been visiting more than, I read, 30 countries for the preservation of historic sites. So I'm very happy that, and I thank him for joining these webinars and for taking time to prepare a presentation. And I will be very happy to listen to it and to see the wonderful sites he has been involved with for their preservation. So thank you again, Claudio, and now the floor is yours.
Thank you very much, really, for these kind words, and I really appreciate very much to be invited in this fantastic meeting, people and friends. It's a pleasure for me to see many friends, but let me start sharing my presentation in order to start my talk. Okay, I think, can you see my presentation now? I suppose yes.
Yes, we can.
Yes, okay. Okay, perfect. So, really, thank you very much to Professor Flora for this presentation, to the President of Indian Geotechnical Society, and to the Secretary General and the many people that were attending this conference. What I'm going to talk and to present, since I'm not very young anymore, so I will tell you a little bit about the history that I faced during my scientific career and practical career. As Alessandro Flora, I was first in the Geological Survey of Italy and then in the Italian Embassy as a scientific attaché in Cairo before my retirement. But in parallel, I was supporting UNESCO and then introducing the engineering geology and geotechnical engineering and rock mechanics in the conservation of heritage sites that in the past were mainly tackled by conservators with limited recourse, unless for some special cases, to experts of earth science in general. So in this presentation, I will discuss about the global context we are going to face, the geohazards and cultural heritage, the framework I'm dealing with, because up to now, a framework has been developed for introducing engineering geology in the conservation of heritage sciences, some case studies, and finally a synthesis and outlook of my expertise in this sector. And the heritage sites I've been working are around almost 90 sites in 30 countries in 4 continents. But this is, as I told you before, because I'm not young anymore. So, and have been spent my life in most of these countries. Mainly, I've been working on behalf of UNESCO in countries which has no local, sometimes no local capacity to preserve and to maintain the heritage and the monuments and sites they have. I've been working, as you will see, in Afghanistan, in North Korea, and many countries that you can see in this map. But going to the general context and why engineering geology and geotechnical engineering are relevant for the conservation of heritage. First, because the heritage represents the legacy of humankind on the planet. It bears witness to millennia of human adaptation to their environment, as demonstrated in numerous monuments, science, and cultural landscape. These historical landmarks are subject to continuous changes and the influence of modern growth and development. The impacts and alteration results from various internal and external conditions arising from both natural and anthropogenic factors, such as rapid events like rockfall, debris flow, slope movements, earthquake, floods, and slow onset processes like geological and geotechnical subsidence, soil and coastal erosion, sinkholes, hydrogeological conditions, including climate change. We will not focus on climate change in this presentation, but this we can consider as a background in our speech. Today, cultural heritage show evidence of the impact of geohazard and weathering, underscoring the need of rethinking the conservation and management plans for these sites. As a consequence, engineering geology and geotechnical engineering, applied geomorphology, rock mechanics, along with technological innovation, may need to introduce new paradigms for the preservation of cultural properties, providing a resourceful platform for learning. This is the rationale that we developed within UNESCO, just to understand how important are scientific disciplines when supporting heritage. But why we needed to protect the heritage using these disciplines? Because if we look, this is a report representing 5 years of survey within UNESCO sites. And as you can see, 25% of World Heritage Sites of UNESCO in these 5 years has been affected by natural events and disasters. They also have been affected by management and legal issues, development, etc. But for sure, natural events and disasters are the most relevant and important for their conservation issue. In the meantime, if we consider, this is a map produced by Irina Pavlova from UNESCO, And if we can see, in this map, we can see the World Heritage List, and with the sites that can be affected by 1 or 2 geological hazards, or 3 and sometimes more. And from this map, we can see that 46 of World Heritage sites could be potentially exposed to at least 1 out of the 4 selected geohazards. In this case, we are dealing with tsunami, landslides, earthquakes, and volcanic eruptions. So if in this map we add the water problems, like floods, for instance, or weathering, we can assume that almost the 100% of World Heritage sites can be in some way affected by geohazards and in general. The hazard we are considering, I used to have this diagram from ICROM because it is explaining very well the relationship and how this discipline is in some way interconnected with many other elements. We have natural causes with rapid onset, like earthquake, volcanic eruptions, landslides, etc. And natural causes impacted by slow and cumulative effect, like climate corrosion, settlement, moisture, soil erosion, vegetation, and so on. But in the meantime, we have human causes like war, fire, public works, and we will see, for instance, in Afghanistan, how war impact require our expertise to preserve some important heritage, like the niches containing in the past the Bamiyan Buddhas destroyed in 2001. So as you can see, there is no real division about these elements, but there is a continuous evolution starting from human to natural causes, from rapid onset to slow onset, and this is giving a general framework of the threats that are facing the cultural heritage. But why heritage sites are inherently geological vulnerable? Because of the selection, sometimes because they are on top of hills for defensive purposes, or because they are rupestриan sites deliberately carved into soft rocks. Sometimes we have artificial topography. You probably know the citadel of Erbil is a completely an artificial mound, or other the earth mounds in many tombs in the Etruscan region or in Goguryeo Empire in Asia. The age and cumulative deterioration that is producing weathering, biological colonization, seismic loading, inappropriate human intervention, previous incompatible intervention, like in many sites we can see, the absence of systematic monitoring, which is the final lack of baseline geotechnical data, and logistical and access constraints, which also is producing problems like in conflict zones or in remote location. And in the meantime, the engineering geology need to be reshaped in some way or refined, because when we are dealing with heritage, we have to follow one of the main important chart is the Venice chart from developed in 1964, that is still active, still in operation, in which it's required that restoration will be undertaken only when necessary. No construction should be omitted, and the structure and the authenticity of materials must be respected. Any new elements should be distinguishable. Whenever traditional techniques prove to be inadequate, recourse may be made to modern but well-tried techniques. Elements of value of any period should be respected. Falsification in replacing missing parts should be ruled out. So this is our main element, principle for the conservation, and also the mitigation of geohazards, as we can see in the future in the other slides, have to follow this international charter. But which are the geohazards that in detail that are affecting cultural heritage? I want to introduce you with just a brief panorama first before going into the case studies. We have rock cliff instabilities like falls and cave collapses in the monastery of David Range in Georgia, the collapse of tombs in Petra in Jordan. This is the Muezra tomb. And the falls and tomb collapses in Nabatean site of Alula, for instance, in the Kingdom of Saudi Arabia. Coastal erosion, like Tipasa in Algeria or Taros in Sardinia, in Italy. Earthquake phenomena. This is also still a rapid onset. We are mainly looking at rapid onset in this moment. This is the BAM earthquake and the Kathmandu, Nepal. After the Durbar Square, this is Durbar Square, 25th April 2015. And slow onset phenomena with, let's say, a limited velocity in occurring. And all the sites that I'm showing here are sites which have been in some way involved. Like in this case, the earth slide forming the Andenas in Machu Picchu, or the site of Barzakash in Armenia that has been destroyed probably by a mix of earthquake and induced landslides. This is a beautiful site at the border between Armenia and Georgia. And still the local community is going to restore, to recover as much as possible, but there is the need to investigate which are the real causes for this destruction. Soil erosion in the citadel of Erbil, this is Kurdistan. As you can imagine, this is the citadel of Erbil, but the citadel, this is completely an artificial mound constructed over 6,000 years of accumulation of materials, 6,000 years. And now on the cliff, in the top, there are some inhabitants and some houses, but on the cliff, there is a continuous soil erosion that UNESCO is going to preserve as much as possible. Bearing capacity, it's another typical geotechnical problem. These are two cases from Afghanistan in Herat, in which the fifth minaret in the town was deeply leaning. And also in the minaret of Jam in Afghanistan. This is in a remote area at the border between Afghanistan and Turkmenistan. In this case, we will see some more detailed example. Still slow onset processes like weathering. Ethiopia, Lalibela, we will see in detail. Just let me to remain, these are beautiful churches constructed in the 12th centuries by the Emperor Lalibela when he was back from Jerusalem, and he decided to construct churches in the place with the highest concentration of Christian in Africa. But these are not construction, these are status, because these churches here has been initially excavated all around, isolating a block, and then this block has been completely sculptured outside and inside. So you can go inside, you can see the altar, the windows, the 2 or 3 floors, and the roofs. All of these are not constructed but excavated. Weathering in Petra, most of you probably know, or in Alula, this is Hegra. This is the second Nabatean town after Petra. We have surface erosion, another important element which can transform and alter, for instance, the memory of the earth, the UNESCO memory of earth, like this place in Abu Hud in Saudi Arabia, or the wind and the surface erosion can damage the site of Aplitsike in Georgia, or the structural stability. There are 3 cases. One is in Mongolia, in the tomb of Bayanur, that was excavated in 2017, but after the excavation it started to collapse. It was necessary to support in the best possible way. Then in Tunisia, in Bulgaria, or in Pompeii, in Italy, cases in which the deterioration and the aging are posing problem for the conservation of the structure, as in this case. Water, flood event. This is one typical flood event in India. This is from UNESCO France, having this picture. But also having floods and heavy rainfall may affect places like Cambodia in Angkor Wat, You probably know very well the situation in Angkor Wat, but also the problem in Lumbini, in which, to protect for floods, they constructed in 78, if I remember correct, 78, 80s, a levees, a circular levees all around the archaeological site. I remind to you that Lumbini is the place where Lord Buddha was born. And but these levees were not well designed for the flowing out of the water. So now the external flooding are not coming in, but the rainfall water falling into the site can hardly discharge outside. Then we have a rising dampness or seepage. This is the case is Petra, or in some tombs, like a problem of condensation, moisture, and we will see one example in North Korea. War, not too much to say about what's happening in Afghanistan, in Bamiyan, and how to face all these different situations. First of all, there is one concept to consider. There is no one case similar to another. So it means that even if we are facing the same problem, the local situation is different, the heritage is different, so we must consider to work as it was every time as it is something new. This is really an additional problem, but it is exciting because there is no possibility to have a similar situation. Maybe some nearby approaches can be developed, but they are mainly different from the others. In this period, within UNESCO, we moved from a reactive approach that was intervene only after visible deterioration or structural failure to a proactive approach, characterize hazard processes before deterioration becomes critical or irreversible. Emergency decision with incomplete geotechnical understanding of failure mechanism was developed in the past, and now we are trying to concentrate to build the 3D engineering geological model and geotechnical model as a scientific foundation for all intervention, to develop non-invasive low-impact investigation as a first choice, not to use incompatible materials as it was done in the past. So this new change of paradigm was really an important achievement inside UNESCO, because from UNESCO can be transferred to all the other heritages in the world. We can say now that when we are dealing with engineering, geology, and geotechnical sciences, we can say that this box is in some way something reflecting the process, the problems. We use our science to understand the problem. But in the meantime, in our experience, we need to preserve integrity and authenticity of the site. So it means the involvement of archaeology and history of art in our work, but very often also enhancing traditional knowledge and local expertise, because this can ensure the realization of mitigation works and measures in many countries in the world, but also ensuring the maintenance and then sustainability. So the result is that the conservation project to mitigate geohazards and other environmental threats is a mix of these elements. We can say a shared culture for a pan-disciplinary approach, using the words maybe from Carlo Vigiani in this case. Just to give you some example of case studies about our work in the past. Egra is the second town, Nabatean town, is based in Saudi Arabia. There are in this place more than 130 Nabatean tombs, most of them affected by collapse, rockfall and slides, planar sliding, fall, so instability from a small to medium large dimension. Tomb facade partially collapsed, roof collapse like in this. This is not a tomb, but this is a kind of caravanserai, small one, and facade deterioration in most of the tomb, but also weathering, like capillarity rising. This is Al Farid, the most important tombs in Hegra, and also in most of other, but also surface erosion of the local sandstone, that is the Cuveira formation. That is a sandstone with a uniaxial compressive strength. This is just to give you an idea, but there are many articles dealing with more detail about our laboratory test. with a uniaxial compression test between 10 to 30, 40, 50, let's say, UCS. We have in our sites also other higher value, and we put as an example, but they have been developed not by ourselves. What we did are just the sky and the gray, and they are just related to heritage sites. The other sites we put as a comparison that have been developed on the same materials, but in different places, just for query probably. In our we developed an atlas for the 130 tomes dealing with the threats on the facade and the possible sliding and developing a data set for this with this data, and then developing a scoring of and the percentage of damage for all these tomes, producing maps like the one we can see in this figure. These elements are of basic importance for the local manager because they can establish priority according to these elements. We used also our maps for understanding the evolution at very small micro scale. For instance, using the 3D kinematic analysis and the alveolization index to understand which part of the cliff can be further eroded and possibly more endangered in the future, then modifying the landscape of the sites. But also using the finite element analysis starting from point cloud. We have a fantastic point cloud in this site developed by Factum Foundations, from which 3D solid mesh solids has been developed and slope stability for almost all the 130 tomes in the sites. But very often we didn't finish with the science. We went into the practical application. In this case, there is a hanging block just over an Nabatean well that is currently visited by tourists. So the local manager, in this case, the Royal Commission for Alula, requested to develop a project for the consolidation. And then we used the 3D model, in this case, Plaxis, to understand the evolution of the cliff with and without dowels and bolts. And then we delivered a project for the consolidation that will be probably implemented in the next steps. So you can see we started from the understanding the problems, and then at the end just developing a practical project and design for the local community. Petra, rockfall, flash flood, weathering, there are many elements in the sites. This is the SIC. In the SIC we have collapse from large block volumes up to 15 cubic meters, medium block volumes, and small block volumes. Sometimes small block volumes like 10 by 10 centimeters is very dangerous. One person was killed in 2018 because a small block was just falling down and just hitting him on the head, unfortunately. And we developed a project for 3 years in Jordan, in Petra. And then after having investigated, scanned all together, in this case with the Cape Town University, scanned the sites, developed the geomatic, geological, geomorphological, and geotechnical surveys, developing a monitoring, both in Wi-Fi, traditional geotechnical sensor in Wi-Fi environment, as well as satellite radar interferometry. And then we developed some conservation plans according to a guideline that we delivered to the local managers in order to be able to manage by themselves in the future. But the situation in Petra is interesting and complicated because if you look at the kinematic analysis, for instance, we can see this is one of the cliff of the SIC, that there are many sites with that are potentially endangered, but how much they are dangerous. So it means the local community, the manager has to monitor, to look at them. This is a case of a block that was falling down in 2015, just 50, maybe 30 seconds before a group of Italian tourists were passing there. And the results was just in a case like this, the blocks could fall down just over the tourist. But this block was exactly one of those that we identified as potential possible elements to collapse. So it means again that the science, even if sometimes a little bit complicated, can provide a very fundamental tools for the local managers to provide a correct management of the site. Machu Picchu, and you probably know the place for sure. In 2001, there was the international appeal, the risk of collapse. There was the idea that the entire cliff could move down, just this part could collapse down. And UNESCO established an important group that then later on became the International Consortium on Landslides. And we had a project in this group, and then we started from the geomorphology, from the investigation, and at that time we developed the first ground-based radar interferometry. It was 2003. Now it's quite common everywhere. And at the end, all the monitoring data and information revealed that this big block that could fall down was probably not a block going into this direction, but it was the result of a geomorphological evolution in which this step in the backside that could leave the impression that this block was already moving in the past was caused by rockfall of blocks in these directions. And also the sliding plan of below the citadel is not going down to the valley, but is going towards the cliff, the mountain that is over there. But in the meantime, our data was completely collected. This is from a PhD thesis for a close friend of us and member maybe of TC, not maybe, member of TC 301 was Daniele Spizzichino. And this data was later on used by the local manager to understand, to identify the areas with the higher priorities for investigations. But going to slow onset soil erosion, this is Bolivia, Tiwanaku. In Tiwanaku, this is the remain of one of probably the largest pyramid before the arrival of Europeans. And it was covered by stones, but the stones were completely demolished to construct houses, churches in the region. This cliff is now affected by soil erosion, small landslides, even if this is completely artificial. This is a completely artificial mound. And we made investigation, mainly geomorphological in this case, and we developed the projects composed by water collection, gabions in the places of high erosion, and impermeabilization of also in the high erosion areas. But how we realized? This is the geomorphological map that we use as a background for the mitigation measures for superficial erosion, for rill and gullies, and development of a new drainage system. We developed a project in which we decided, considering the original structure, to place the gabions in the positions where the original steps were in the past. In other words, even if we are in areas in which we have important erosion, like in this area here or in the other, we decided that the gabions should follow possibly the original morphology, the original shape of the constructions. And this was developed by the local community that also found the possibility to have some incomes. And the gabions were constructed with local stone and local materials, and then completely integrated in the environment. But this was not enough. We had the problem of erosion, surface erosion. And in this case, we decided to impermeabilize the surface in some cases using an ancient Inca techniques. That means to develop a soil composed by mud, straw, and boiled cactus juice. These materials altogether is then compressed, like in this case, with tools that are the same tools at the times of the Incas probably. And finally, this was completely making impermeable the surface. It's not lasting forever, it's lasting 4 or 5 years, but this is giving the possibility to the local community that are using these techniques to impermeabilize the houses, for instance, to work periodically in the site. In 2024, when we visited Daniele Spizzichino, visited again the site, as you can see, the place is completely vegetated. So it means that the approach was successful, and now there is no intense erosion anymore. Jam Minaret is a place where we are working this period with Alessandro Flora and Professor Lancellotta, and is a place in which the under excavation during the century was probably moving this high tower. This tower is now 64-meter high and leaning 3.4 degrees towards the river. And the major threats was mainly due to the high erosion and floodings. These are 2007, 2019, 2024. But the under excavation in 60s was so important that was probably, as we can see in this image, for instance, the river was really close to the foundations. This was probably the reason for the leaning of the minaret. This minaret is in Jam, at the border with Turkmenistan. The entire town was destroyed by Kyrgyz Khan in 12th centuries, and only this tower remained, the minaret remained, and probably the town is still in the valley to be discovered, because, as we can see from the minaret, the original entrance of the minaret is 4 meters below present-day topography. So it means that we have at least 4 meters or even more of alluvial deposit in the valley that are covering the original constructions. And we also got information with GeoRadar about this presence. And but this minaret is also in a conditions now in which the leaning was increasing the stress, the vertical stress in the direction of the leaning. And if, according to some preliminary data, we have erosion of the embankment again, as it was in the past, and increasing of the floodings, and then increasing of the water, we are not so far from the acceptable bearing capacity for that soil. In this moment, UNESCO was also placing some tilt meters because you can imagine there is no electricity, no mobile phones. And this tilt meter are giving the idea that the minaret is, this is some preliminary data we developed just yesterday, for instance, in this case. And there is still some movement in the direction of the, but limited movement in the direction of the leaning, but still is not calibrated with temperature. But anyway, instrumental monitoring, even if in this case preliminary, can provide important information for this kind of data. Ethiopia, Lalibela was mentioning before about these churches. These churches were affected by weathering. Is a basalt scoria affected by weathering. I'll try to be very fast. These churches, we found that where this was not discovered before, was in this material, in this basaltic scoria, there is an important percentage of smectite clay materials, mainly montmorillonite, that are producing the erosion of the top. So with UNESCO, we suggested to cover the roof. Now there was a project of the European Union that was covering with the European Commission, covering with some kind of not very nice structure, but now they are working for a possible removal of this and then producing something, implementing something more comfortable to the local landscape and archaeological sites. Using techniques can be important also in this case in Rapa Nui, in the Moai, in the Easter Island. We use the geophysical techniques to investigate. This was for the first time using seismic tomography to understand that the most external part of the Moais, this is the border of the Moai, is affected by weathering. So it means that we have to pose attention also in the evolution of these monuments during the time. Abu Hud is in Saudi Arabia, also is a place affected by surface erosion. This is something very complicated to solve, but at least we can now monitor an evolution of the digital photogrammetry. We developed special cameras with special objectives from which we are able to achieve a point cloud with 5,000 pixels per square centimeters at 100-meter distance, while in the meantime, our laser scanner is having 1 pixel per square centimeters at 100-meter distance. So this is a completely, you can see some example with the cloud compare here. In this image, what you can see is not a figure. This is just the point cloud that is so high definition that there is no need to mesh or other techniques to give you the impression of the results. With these techniques, we can understand the evolution because we can make the survey of the petroglyph, then to identify them, digitalize, and then to have a 3D vector to monitor periodically. Going to another example, this is Susanri in North Korea. This is a fantastic example of tombs and affected by weathering and the infiltration of water. And in the past, it was not very well explained why this water was infiltrating. After that, from 1,500 years, there was no infiltration inside the tombs, painted tombs belonging to the Goguryeo empires that was ruling this country from South Korea till northern China and till the border of Manchuria in the 2nd century BC until 8th century AD. So we discovered that there was a water infiltration in the mound, but because the mound was completely reconstructed in the 60s, this mound was completely eroded, then the local community decided to reconstruct. And they reconstructed it with sand without having the same attention that in the past they did, not using a compressed earth, for instance, or clay to avoid infiltration. So this one was acting as a sponge after the 60s when they restored the tombs, and also there was some ephemeral water table in the lowest, in the underground. Finally, we decided to use not to make it impermeable because to make impermeable is dangerous since the mural paintings can be damaged if they are too dry, they can produce salt. We decided to have a filter just on the surface and then to discharge the water out. We used these techniques together with some companies that were able to import the material in the south, in North Korea. We installed some piezometer, but with very simple techniques. So this is an example in which we have to solve the problem. We have to understand the process, but we have to finally implement with what we have. And what we have in North Korea, for instance, is mainly people. And then we use the people to remove the 5-10 centimeters to place the filter and then to remove the water. And after that, there was not any more humidity inside. Bamiyan, Afghanistan, you remember the destruction in 2001. Very simple, the geology of the site was very complex. There were no information. And mainly there were two materials, like the conglomerate and the siltstone. You can see with the yellow and red in this figure. But the siltstone was completely slaking. So when we decide after the explosion to consolidate the cliff, because even the cliff and the niches were going to collapse, using anchors and nails, we had to use a different kind of equipments, and especially not to use water for cooling the head when we are close to the siltstone, and also not to use instruments having vibrations when we are close to the cliff again. So all this approach of balancing vibration and slaking was successful at the end of the for the consolidation of the cliff that was done in 2005, 2007. After that, we consolidated also the back wall, also restoring the remainings of the plaster of the Buddha using local communities, local experts, people, especially trained for this approach. Monitoring, again, important, Pompeii structural deformation. We used in this case the the satellite radar interferometry together with some Italian companies and IGEOS to understand if satellite data can be useful as a premonitory information for collapse. And since collapse very often is a rapid phenomena, the successful is partially, the results was partially successful. Now we are at the end. I want just to remain somebody that was developing some things before than us. It was just the father of the Venice Charter that we mentioned at the beginning of this presentation, was Piero Gazzola, that was also the responsible of the first project for moving Abu Simbel from the original position to a safer one. But mainly he was just a kind of a father for rock mechanics for cultural heritage, because for the first time he surveyed the status, he identified the many cracks, developed a project for bolts that are in green in these maps for the consolidation. And we had an exhibition in 2022 in Egypt. About Piero Gazzola. But I'm very happy also to say that we were in good company in 15th centuries. Also Leonardo da Vinci was drawing the first landslides. And these landslides now this drawing now is in the Queen's Gallery in Buckingham Palace. But as we can see, this is exactly the design of landslides that was probably drawn by him during one of his way from Milano to Paris. This is an example, not to say an heritage, but to say that heritage sometimes gives information also on the evolution of territory. Conclusion, and the protection and conservation of heritage is a science at the border between earth science, rock mechanics, archaeology, history of art, finally, social science when operating local, especially when operating in local Incan countries. To maintain the authenticity and integrity of the site and mitigation project as to provide effective solution, very often innovative, but to be combined with original architecture and environment. The harmonization of advanced solution with historical heritage further require a mitigation project, sometimes a pioneering, with a design that is minimizing the impact of new intervention, possibly recovering traditional materials and or solutions, or the reuse of original construction techniques. So in low-income countries, the usage of original construction techniques also ensure maintenance by local workers and then sustainability. So conservation of monuments then is something regarding a complex endeavor regarding the contribution of many heritages. And finally, we can say that a pan-disciplinary approach is required. So in our experience, we can say that we were able to work in proactive model, non-invasive first. These are the pillars that we developed in our work. Diagnosis is not negotiable, so we cannot make a very simplified approach when we are dealing with heritage. Authentic, minimizing intervention. Traditional science, traditional knowledge is a science, is not simply something humanistic and descriptive. Climate change is already here, so we have to consider the climate change, even if we didn't discuss because of time in our as a background in our approach. Finally, it means that in our work, we have first to understand the other process and then design in order to preserve integrity and authenticities, then enhance traditional knowledge. This is exactly the box I showed at the beginnings, and this is exactly what we try to do in our work and then in our approach. And thank you very, very much for listening to me. And I really wish to thank all of you, but I wish to thank UNESCO for giving to me the opportunity to work in so many sites and to help, especially communities that are not the energy, not the strength, and not the capacity to work by themselves in this protection works. Thank you very much.
Thank you, Claudio. Your presentation was really, really super interesting. I found it excellent. Also, well, first of all, because the pictures are amazing. I mean, I envy you. You have been in so many sites that I wish to visit, and I really appreciated also that you stressed the idea that. We have to consider local expertise because very often historic sites are in places where we don't have access to modern technologies and also modern monitoring, instruments. We have, as you mentioned, we are experiencing this in our common work on the Jam minaret in Afghanistan. So it is very important to consider local expertise, also to preserve authenticity, of course, and integrity. So indeed, thank you very much. I remind all of you that the webinar will be visible, will be recorded, has been recorded, and will be on our website because we have our own website. I invite all of you to check our website, which is TC301 Historic Sites. It is out of the ISSMGE website. So we built our own website where we put news, information on new, also new conferences, and we put also our webinars. So you can look again at the marvelous pictures Claudio showed and very smart solutions they found. So thank you all for taking part of this webinar, and I hope to see most of you in Vienna, possibly, and I hope to see you also at the next webinar here. Bye bye.
Thank you, Alessandro. Bye bye.
Thank you. Bye.
See you soon.